So let's start with question 1I. Right? The question says expand the following using double angle formula. Our double angle, I wrote them there. Okay? We're supposed to use those double angles. So 1I, we have minus cos 86 degrees. Please take note here, the cos 86 is negative, right? So this is like the left hand side of number 2. Okay? That's like the left hand side of number 2. So this will be equal to minus cos half of 86 is 43, so it will be minus cos 2 times 43 degrees. Okay? This 43 degrees is like the theta here, and that theta. So I can write this as minus open square bracket cos squared 43 degrees minus sine squared 43 degrees. If I remove the brackets, I'll end up having minus cos squared 43 degrees plus sine squared 43 degrees, which I can write by swapping the sine and cos as sine squared 43 degrees minus cos squared 43 degrees. But if you stop here, it's too fine. Okay, so I'm going to leave my answer there like that. Please do me a favor. Be serious. Next time I'm going to give you 3 assessments. One of them is going to be a June examination. The trig will be there. And these double angles are going to be definitely tested. And you also write a standardized test on this too. All right. So if you don't come to school, you are disadvantaging yourself in a very big way. Okay? And you must tell your friends who are not here that it's not a good idea what they are doing to stay at home. Right. So this is the question I've done by using the double angles. Right. Is there anybody who has got any question before I carry on?
What is the negative cos squared for plus?
Yeah, because there is a minus in front. We have got this minus here. So negative and positive gives you a negative cos squared 43. Negative and negative, there's a negative here. So these two negatives give you what? A positive. Then I swapped the cos and the sine. Alright? So this is what you're supposed to do. It's very disappointing that some of you didn't know what homework is. But that's the purpose why we're having the WhatsApp group. Communication. Alright, the next question, number 2D. Number 2D says, write as a single trigonometric function. Write as a single trigonometric function. So we have 2 sine 35 degrees times cos 35 degrees. This is equal to. Now, if you look at our double angles there, there is a product of sine and cos, and there's a 2 as a coefficient there. So it's like number 1, which means I can write this as sine 2 times 35 degrees, which becomes sine 70 degrees. Right? Now, there is no need to convert it to cos. But if you want, you can. But this could also be written as cos 20 degrees. But the best answer would be to stop there. Right? That's what I would suggest. If you want to convert it in ratio to cos 20, it's fine. But you just have to stop at sine 70. That's okay. All right? Okay. So let's move on to 2J. 2J, I'm going to do it on the side here. I'm going to use a different color. So we have got 1 minus, so that's 2J. We have 1 minus 2 cos squared 22 degrees. Right. Now, if you look at our double angles here, do we have a double angle that looks like this? We have got 1 minus 2 sine squared theta. We don't have 1 minus 2 cos squared theta. Okay? So, if you want to carry on here, right, you can factorize. Okay? You can factorize this. So if you factorize it, we take out a factor of minus 1. So we end up with minus, open bracket, minus 1 plus 2 cos squared 22 degrees. Okay? You saw what I did there. I factorized. Okay? What answer are you getting? Minus 0.7. Huh?
Yes.
Yes. And then, well, what's minus cos 44? Minus 0. See now. So the answers are the what? Are the same. And please take note of what I did here in this step. That factorization is very important to create a double angle of cosine, that is number 2. Okay? Any question? Right. If you don't have any question, then let me move on to that one. Okay. So I'm going to move on to the next page. So we have got question 2K. We have cos 2 theta plus sine 2 theta times cos 2 theta minus sine 2 theta. Now here we are going to use FOIL. Okay, cos 2 theta times cos 2 theta, that's cos squared 2 theta. Cos 2 theta times minus sine 2 theta, that's minus cos 2 theta times sine 2 theta. You following that? Then this sine 2 theta times the cos 2 theta, I can write that as positive cos 2 theta times sine 2 theta. I've decided to start with cos. You can also start with sine. Then sine 2 theta times minus sine theta gives me minus sine squared 2 theta. These two are like terms, right? And they have opposite signs, so they cancel out. Okay? Then you'll be left with cos squared 2 theta minus sine squared 2 theta, which is number 1 of the double angles for cosine, which I told you that I call it the mother of the double angles for cos, because there are 3, but that's the main one, right? Since we have got 2 theta here, it means if we want to move from the right hand side toward the left hand side of the double angle for cos, we have to multiply this 2 theta by 2. Okay? So we end up having cosine of 2 times 2 theta. This is where the concept of the double angle comes in. And then you end up having cos 4 theta. So that will be your final one. Okay? You follow? So this is what you were supposed to have done over the weekend.
Candidate little girl, start making their way towards the turning circle, please. Next girl.
Okay, I just want you to be aware, boys and girls, that maths is not a subject that you will pass easily. No matter how smart you be, it requires a lot of effort. If you are lazy, you will never succeed in maths. It will never happen. Okay? It requires a lot of effort. If you you are lazy, you will never go in with maths. All right, let's do this one here. I just want you to be aware that it says show that sine 8 theta is equal to 8 sine theta times cosine of theta times cos 2 theta times cos 4 theta. Alright? Now, because of this cos 4 theta, the angle 4 theta itself is the one that I'm going to start with. So I'm going to simplify the left hand side until I get the right hand side. Simplifying the right hand side is very complex until you get the left. So I'm going to start with the left hand side because I can use my knowledge of compound angles together with double angles. Okay? Remember, we have done compound angles. Don't forget that. So you are expected to apply now the compound angles together with the double angles. Okay? So here I'll say the left hand side is equal to sine 8 theta. But the 8 theta I can write it as, well, I'm gonna use compound angles. So I'll say sine 4 theta plus 4 theta. Okay? Following that, then this becomes sine 4 theta times cos 4 theta, right, plus sine 4 theta, right, times cos 4 theta. Now, if you look at it, the way that I'm doing, I could have started using double angles straight away, but I think this is, well, even if you see that these two are like terms, I'll come to the double angle. See that? So I can write it as 2 sine 4 theta times cos 4 theta. Fortunately, the 4 theta is now coming out. So the next stage now is to split this 4 theta, okay, using double angle. Now I've realized that there's no need for me to use compound angle. Let me go direct to what? Double angle for cos, sorry, for sine rather. So this sine 4 theta, I can write it down as this. So I can write this as 2, because there's this 2 here, I have to open a bracket. Okay? I've opened a bracket. Now, sine 4 theta, what is half of 4 theta? It's 2 theta. So, if I use the double angle for cos, inside the bracket I have to write 2 sine 2 theta times cos 2 theta. Then I close the bracket. Okay? Because I'm only simplifying this sine 4 theta. Right? Take note that I'm only simplifying that. The 2 and the cos 4 theta, I'm not touching them. Okay? I'm using the double angles here to simplify the sine 4 theta. Yes?
So you have to remember that 2 plus y times 2 sine theta 4 sine.
Okay. We are moving from the left hand side to the right hand side. There is a 4 theta here. So here we always have a 2. And here you have a 2 theta, here you have a 2 theta.
I see. My question is why is there 2 sine?
This 2 here, it comes from here.
Get that sound too much inside there. The 2 sine.
This 2 here, it comes from simplifying the double angle. We are applying the double angle more than once.
Alright.
Okay? So this 2 here, the first 2 is for the 4 theta case, whereby I use the compound angle there until I got it. Then this 4 sine 4 theta, I also need to apply the double angle. So I'm going to create another what? Another 2. Remember, look at the right hand side. We have got this one. There is an 8 there. So that's how you create the 8. So the 2 times 2 gives me a 4. I need to do it for the third time to create this 8 here. The 8 on the right. Do you see that? Yeah. Can you look carefully? So I'll get 4 sine 2 theta times cos 2 theta. Here, please put cos 4 theta. So that will be times cos 4 theta. I'm not done. This sine 2 theta here, it's a double angle. Now, if you look at our original question, right, I now have the cos 4 theta, I have the cos 2 theta is here. So I have got that, and I've got this, based on the right-hand side of the question. Now, I'm left with the sine theta, cos theta. To get that sine theta, cos theta, I need to use my double angle here. Fortunately, the sine 2 theta, it looks like that, right-hand side, 2 sine theta, cos theta. So, if I simplify it, I'm going to have 4 times 2 sine theta times cos theta times cos 2 theta times cos 4 theta. So that will give me 4 times 2. I'll get the 8 sine theta times cos theta times cos 2 theta times cos 4 theta. Then I can say the left hand side is equal to the right hand side. So I've used the double angle 3 times for me to end up having that coefficient which is equal to 8. All right.